In this question, we have to use this equation, and we can either work out the triangle from that, or you may remember the triangle is amount, concentration, volume. And this, the way I remember this one is a chicken vindaloo. So let me get the order in the right way. And the question says calculate the concentration. So we're going to use the equation exactly as they've written it down. So the concentration is the mass, the amount of stuff divided by the volume. So in this question, we have got 3.14, so 3.14 grams, and they have got that in 250 centimeters cubed. Watch out for this, because that's centimeters cubed, and if you see here, it must be in decimeters cubed. So the way I convert that is I divide that volume by 1,000. So here I've got 3.14 divided by 250 divided by 1,000, okay? And that's given me an answer of 12.56, and that's grams per decimeter cubed. You get 2 marks in here for this, so you obviously get 1 mark for the answer and then 1 mark for this stage here. Okay, sodium hydroxide solution was added to a solution of copper sulfate, a precipitate. Explain what would be seen. So a precipitate of copper hydroxide would form. Explain what you would see. So as soon as you get a precipitate, this means you're getting an insoluble solid forming. So an insoluble solid would form. And the core knowledge, the thing we've got to remember is that is what precipitates are. They are insoluble solids. Okay, complete the balanced equation by adding a number in front of the sodium hydroxide. If we just look on this side of the equation, there are 2 lots of sodium. So we've got Na2, so 2 lots of sodium. So if I'm going to get 2 lots of sodium on the other side, what I'm going to do here is put a big number 2 in front, and that will make it correct. So describe how you'd obtain a pure dry sample of the precipitate of the copper hydroxide. Let's just remind ourselves, we have got, this is my copper hydroxide, this insoluble solid, and this solid is sat in a solution of different chemicals. So there's my solution, there's my solid. So how am I going to get that insoluble solid out? Well, the first thing I will do is I'm going to filter this mixture, and that means that the insoluble solid, the copper hydroxide, will stick into the filter paper, so it's separated from the solution. How are we going to get a pure? How do you make it pure? What you would then do is you would wash the copper hydroxide. So wash the copper hydroxide with distilled water. So that's water that doesn't contain any other ions. And then number 3, is you would then leave it somewhere warm to dry. Okay. Okay, next little bit, we've got electrolysis set up for sodium sulfate. Graphite electrodes are being used. Figure 7 shows the ions. State why is important. Figure 7 shows the ions in sodium sulfate solution. Draw and circle the ions that are attracted to the negative graphite electrode. So if you remember, the rule in chemistry is opposites attract. So if I've got a negative electrode, it's going to attract the positive ions. So the ones that it will attract are the hydrogen and the sodium ions. Why is it important for those to be inert? So if you remember what the word inert means, that means unreactive. So that's important because they do not take part in the reaction. So they do not take part in the reaction for 1 mark. Explain in terms of its structure how graphite conducts electricity. So graphite conducts electricity because if we look at the structure here, this carbon contains 1, 2, 3 bonds. So this means it contains delocalized electrons because carbon should make 4. It's only making 3, so it's got this spare electron, it becomes delocalized and is free to move. So what we need to say here is it contains delocalized electrons which are free to move. And marks wise, 1 mark for each of those 2 sentences.